allow me to confess two things. So on the one hand side, I am truly passionate about textiles. And on the other hand side, I'm also truly passionate about sustainability. But also, as we've partly seen yesterday, I think the two of them, so textiles and sustainability, are in many ways not yet compatible. So according to the European Parliament, and that was fairly shocking to me, to be honest, according to the European Parliament, the fashion industry, as only one part of the textile industry, is responsible for another 10% of the global carbon emissions. So just to give you an idea on how much this actually is, it's somewhat comparable to all international flights and also maritime shipping combined. So however, I would consider myself to be in a lucky position of belonging to a company that is utmost eager to tackle challenges related to sustainability with conviction and also commitment. So what we have done is we have looked into what it takes from a raw material perspective to contribute to a more sustainable textile industry. And as for today, I would like to highlight all those material developments that contribute to a much more sustainable textile printing industry. So with this being said, allow me to briefly elaborate on Covestro, because I'm not sure how many of you are really familiar with us. So we as Covestro aim for climate neutrality by 2035, which accounts to, on the one hand side, our own emissions, and on the other hand side, also all external energy sources. So we are one of the leading suppliers of premium polymers, and therefore we see ourselves as, on the one hand side, part of the solution, and on the other hand side, also as a front runner, enabling multiple different industries to become more sustainable. So our materials are really used in nearly every area of modern life, and then also multiple different industries, whether it's automotive, healthcare, construction, energy, cosmetics, and many more. So despite the ongoing challenges of the pandemic, we strongly finished off the past fiscal year with roughly 15.9 billion euros in sales, building on the innovative mindset of 70,900 full-time employees. So as of last year, we acquired DSM's resin and functional material business that many of you might know. So this, of course, substantially furthermore expanded our portfolio of sustainable coating resins, and which is also part of the reason why we now operate at roughly 50 production sites globally, ranging from smaller sites, mainly designed for regional purpose, all the way to world-scale plants, which ensure a both reliable and safe and also efficient supply to our customers with a global presence. So that being said, we do not only produce materials, we also want to tackle fundamental challenges. This is for us really the shift towards a circular economy. And this is also part of the reason why we are innovating efficient ways together with our partners and customers to close energy and also material cycles. So if by now still you have no idea about Covestro, maybe now something will ring a bell to you, because Covestro is actually previously biomaterial science. So yeah, the founder of Bayer, so Otto Bayer, first discovered polyurethanes, which is also part of our history. Respectively also Hermann Schnell, who first discovered or succeeded in synthesizing polycarbonates. And we are utmost eager to push boundaries, especially in terms of sustainability. And with this being said, over 1,000 employees working in the R&D really put sustainability on the top of their list. Now looking into the textile industry at first and foremost, I think sustainability, and I think we probably all agree on this, is a topic of great urgency. And allow me to elaborate by starting off on the bigger picture. The what is now European Union introduced a 5-step waste hierarchy back in 2008. And this is meant to serve as a tool to evaluate processes that protect the environment by including resource and also energy consumption. So pretty much you can easily see that the most preferred option certainly is to prevent waste, and the least preferred option definitely is disposal. And without going into detail at this point in time, I can already tell you that the textile industry is definitely ripe for disruption. And I would like to underline this with some facts. So the fashion industry accounts to 2% of the global GDP, which makes it the 7th biggest industry in the entire world. Sadly, it's also one of the biggest polluters in the entire world. And this goes back to the fact that amongst others, there's a greenhouse gas emission of 1.2 billion tons from textile production. And I think there were also some aspects mentioned yesterday. Of course, textile production itself is mainly taking place in Southeast Asia. So almost 2/3 are being produced up there. And the economic viability that is to some extent really gained by producing in Southeast Asia is to some extent also lost in the end market, taking the fact that 30% of the textiles are expected to never be sold. So this is quite a lot, I would say. And why is that? The bare and foremost reason, I think, is that brands heavily engage in overproduction. I do not only want to blame it on the brands because it's certainly a more complex structure, but really it's about the fact that more textiles are produced. And this goes back to the fact that on the one hand side, there's a shift of consumer preferences. And this is, I think, going quite rapidly. And it's therefore quite difficult to make accurate predictions of changing fashion trends. Second of all, it's really about the desire to save on expenses by using economies of scale. So just producing a lot more and yeah, therefore being left with some textiles. It's an attitude of constant purchasing on the end of the consumers for sure. So there's an overbuying attitude. And this, in contrary, is, I think, a motivation, nevertheless, for many brands to really also meet the needs or meet the demand. And the last point is really about inaccurate market predictions, which oftentimes leave companies with a great abundance of unsold inventory. So in this context, I think it is quite clear that on the one hand side, the textile industry is characterized by overproduction, and also that in the context to the 5-step waste hierarchy that I just introduced, there seems to be quite a gap in between. So we at Covestro have looked into how we can contribute to minimizing overproduction, respectively, to create a more sustainable textile industry. And first and foremost, we then looked into what it takes to create a sustainable textile industry. It's pretty much about 3 facts. It's about the ability to deliver within short times to market. It's about cost-efficient individualization in terms of mass customization. And last but not least, it's really about efficient processes with sustainable materials. And materials, of course, this rings a bell for us at Covestro, and our sphere of influence in the textile world strongly relates to polyurethane dispersions and also isocyanates for textile coatings and also screen printing inks, which is part of the reason why we have looked into the textile production chain or value chain and started off by looking into finishing solutions, respectively printing solutions, to see which kind of lever we have in this context. And now diving pretty much into the, I would say, maybe state of the art in the textile printing world, certainly the majority of all textiles is relying on analog printing technologies as screen printing. So it's certainly the predominant technology in the industry and has largely also pinnacled to its full potential. So it relies on stable processes with mature material solutions. So I think this is quite well known. However, now given the high demands towards increased sustainability, less production waste, individualization, and being short or being able to deliver within short times to market, we have looked into alternative printing technologies, which is inkjet printing. And for this digital printing technology, which as of today just accounts to roughly 7% of the entire market volume, which is somewhat comparable to 3 billion square meters of digitally printed textiles. It's a new and disruptive technology, which for us means it does also require advanced formulations, but also a re-evaluation of all raw materials that have been employed until now in screen printing. I think we just heard it also in the panel discussion that on the one hand side, the machinery or the equipment needs to be needs to make a match with the fluids, I think you said. And on the other hand side, of course, we from the more fluid or component perspective, of course, have to make sure that we can match the requirements set by the equipment. So this being given, and I would dare to say that, as many of you touched upon, I think reactive dispersed inks and also pigment inks yesterday, allow me to make this rather short. So we have looked into which kind of ink technology we should be looking into. Now I already went a little bit too far, but starting off with reactive acid and dispersed printing, really it does require a lot of process steps. Hence, from a plain sustainability point of view, there's a lot of energy and also raw material consumption. So hence I would say there's some room for improvement. Dye sublimation as definitely the much more preferred option as of today is certainly leading to extremely nice color intensities, really good image qualities. But given the fact that you first of all have to print on a paper, and the fact that the printed textiles themselves start to deteriorate much faster, so under the exposure to UV light they are not as durable, you also have I would say maybe limited product lifetime, which of course from a sustainability point of view is also not the top of the notch. So really pigment printing caught our attention, given the fact that as of today, still you just have to apply the pre-treatment though, but apart from this, you have no steaming, no washing. So we looked into whether this as a more sustainable or possibly more sustainable way to go would be something that we should be taking a look at from our point of view. So still pigment ink or pigment inks in this, I would say, still small sector of digital printing with inkjet is something that's still small, but it's exhibiting the biggest growth. Part of the reason really is that, and I just mentioned it, there's less energy needed. Also, you can print on any kind of textile substrate as the effect is just based upon physical bonding. So there's no match required between ink and textile substrate. And you will find good durabilities of the printed textiles. What was really decisive for us that in contrast to screen printing as the analog printing technology, we find an 85% waste reduction when switching to digital printing with inkjet and with pigment inks. Mainly going back to the fact that there is a lot less water needed, possibly to clean the screens for screen printing, and also you do not have any excess waste. So now it looked quite promising to us, but what we found is that, of course, any rapidly evolving technology comes with a lot of challenges. And those challenges are, from our point of view, really twofold. On the one hand side, it relates to the process itself, and on the other hand side, it relates to the application. And starting off with the process itself, I just said, well, you can print on any kind of textile substrate. Yes, you can, but still you have to take into consideration that the material, but also the structure or the topography will in the end still affect your image quality. So still the substrate is one major challenge, but really it's much more about pre-treatment. And I think this was also something that was heavily discussed yesterday and also yesterday night, how to get rid of the pre-treatment. Is there a chance to do so? Because as of today, you would still need it in order to really create high quality images. Really, I think one of the core challenges we, however, do see when it comes to the printing process itself, so really creating a stable process is certainly on the top of our list. And with this being said, we oftentimes, of course, find film formation inside or outside the nozzle, which leads to clogging. This was also just discussed now, so I think it fits in perfectly fine. And also the necessity to really adapt the inks to the print head in use. So this, of course, somewhat limits also the range of application maybe today. And when, last but not least, looking into the curing process itself, what we know of today as, I think for the state-of-the-art solutions, you still need to cure at roughly 150 to even 160 degrees Celsius. And just thinking about the fact that if you were to be able to cure at lower temperatures, that would just as well have a huge sustainability impact. So it's maybe also sometimes the seemingly less attractive, but really more impact decisions that one could take. Oh, apologies. Last but not least, it's about the curing times. So oftentimes there's a lot of propylene glycol used as a humectant to really avoid nozzle clogging, and hence, of course, in return, this does lead to longer curing times, which is certainly not desired after all. This was the process part. Now coming to the application, I think here it's much more simple. Basically, we do see a trade-off between handle properties and fastness properties. And for fastness, we majorly concern the durability of printed textiles under the exposure to external factors, washing, scratching, abrasion, etc. And we do see that for state-of-the-art solutions, which may be acrylic-based or also UV-curing binders, they are either way tacky or maybe show limited wash fastness, or they show rather hard handle properties due to the nature of the increased number of double bonds. So this being given, it was our motivation to really see which sort of binder, and of course our assumption was, could polyurethanes be the potential binder solution, which binder selected does help to resolve the remaining challenges, both related to the process and also the application. So for polyurethanes, they have a long track record, as also mentioned up front, in screen printing and also textile coatings, which goes back to the fact that they have a high film building ability, very good mechanical properties, soft handle, and high brilliance. So we thought, why not take this, I would say, to a really high extent proven material solution from the textile coating and screen printing world to somewhat use those intrinsic properties and reformulate or develop new products that are in the end suitable for an inkjet process. So we used this to define some technical requirements, and what we ended up with is, amongst others, a product called Impregnil D1602, which is a polycarbonate backbone polyurethane dispersion. And what I would like to highlight is this potential binder solution for inkjet printing does show two criteria, or actually three criteria, which make them especially favored for inkjet printing. Certainly, it's about the particle size, which is comparably low and also within a very tight distribution, which you would not need for textile coating applications. It's about a rather low viscosity, below 200 millipascal seconds, and it's about the increased shear stability. So we measured this one by using a capillary rheometer, as you can see on the top right. So it's a homemade ring slit device that we used, and for this one we pretty much measure the flow-induced aggregation and aggregate retention by measuring the pressure drop across the ring slit device. So in a nutshell, if you have a very shear stable product, you will find a rather constant low pressure throughout the entire time of measurement. And this is what you can see for this orange line in the graph. So this is Impregnil D1602, which does show this rather constant pressure at a shear rate of 375,000 reciprocal seconds. And the reference with poor stability is actually also something from our portfolio, but luckily not from the inkjet portfolio, but from the textile coatings portfolio. But therewith, I think you really see what kind of like maybe small differences are needed to really have a product that's suitable for inkjet printing. Last but not least, just one point I would like to highlight is the modulus at 100%, accounting to 3.8 megapascal. So this for us is always an indicator that we can achieve soft handle properties. So maybe just keep this in the back of your mind. What we then did is we wanted to evaluate whether we can use the polyurethane dispersion as a binder in a pigment ink formulation and whether we can achieve good printability and also good application performance. So for this one, we started off by formulating an ink. This is just maybe an exemplary formulation that we openly communicate, knowing that for the ink producers, it's their secret, of course, but we want to, have some discussion base. And what we do use is pigment dispersion from Fujifilm from the RxD series. We use then our Impregnil D1602 as a binder. Imprafix 2794 is also from our portfolio. It's a blocked polyisocyanate, which is furthermore intended to be used as a crosslinker to furthermore increase fastness properties, which in brackets, or maybe not in brackets, can be cured at 135 degrees Celsius. So this could be a potential advantage from the energy point of view. Then again, water, of course, to adjust the overall viscosity, propylene glycol as a humectant, as well as further surfactants and wetting agents to furthermore optimize the jetting performance. So for this one, we used a Dematic materials printer, DMP 2831, certainly more a lab product. I'm 100% aware of this one. And what we first of all wanted to do is we want to check whether we can achieve a good jettability and long open times. So we looked at the drop watcher, and I would dare to say that there is some room for improvement given also the many printhead producers in here. But what was utmost critical for us was that we do not find any nozzle clogging, that we have the desired droplet speed of 6 meters per second, and last but not least, no ligaments. So this was for us just the first indicator on really getting a proper jetting. So we then printed on 2 different kinds of textile substrates. One of those was a polyester elastan woven structure, which we did not pre-treat after all. And we did evaluate the wash fastness, crock fastness, and abrasion resistance according to industrial standards of this 1-layer printed exemplary image, I could say. And as you can see from the grayscale rating, it really did show excellent fastness properties, especially given the fact that we did not apply it pre-treatment beforehand. So I think also in terms of image quality, I hope you can see it fairly well. You will find that just given the fact that it's a 1-layer print and no pre-treatment, I think it's quite good. So this made us quite confident. However, of course, we also wanted to check the suitability for other substrates. I also brought some samples with me in case you want to see it in live. We also printed on 100% cotton knitted textile. This one we actually did pre-treat, also with a polyurethane dispersion from our portfolio, but this one wire foulard, so the analog version, maybe also in the future, then also applying this one digitally to avoid some sort of, lack of, or not lack, but excess material. And for this one, we found comparable fastness properties, little bit, I would say, decrease in performance, which oftentimes went back to the fact that the textile substrate itself started to get damaged before we could actually fulfill the entire test. So I think that was quite fine. So this was it for our internal investigations. We, however, in the run of the entire activities that we are enforcing in the digital printing world, we are utmost eager to work with a lot of customers of ours to really, jointly elaborate on the potential of the polyurethane dispersions as a binder solution. And so Bersa, for example, a company and a partner of ours from Turkey, maybe it's also a nice story. They are a screen printing ink producer and now realize that there's a shift needed towards also inkjet printing. It's maybe a typical customers of ours. And they have tested the same with an Epson printer. And you can see that there's actually a good color intensity, and they also claim to us, and this, of course, we would like to believe them that they could resolve the trade-off between fastest properties and handle. So maybe just as an interim summary for now, why polyurethanes? Really, I think polyurethanes as such are an established technology, material technology when it comes to textile coatings and screen printings. So checking maybe the textile application performance. At this point, we were able to design an inkjettable dispersion. And last but not least, we could prove that this inkjettable dispersion is also suitable to be used in a pigment ink, which leads to good color intensity and appropriate fastness and also handle properties. And last but not least, really, we do see polyurethanes as a one-stop shop solution, and this is when I'm then starting with, my enthusiasm for the material technology. Really, you can use it for the pre-treatment as a binder for the pigment dispersion, and you can also use it as a top coat, which of course gives you some reliability when thinking about the interactions between the different layers. So this being said, allow me to summarize maybe the key messages of my talk. For me personally, I really think that on the top line, there's really this urgency in the textile industry to switch towards more sustainable solutions, whether it's material solutions, processes, business models, etc. We at Covestro strongly believe that digital textile printing with pigment inks is part of the solution of this transformation to a more sustainable printing world, also allowing to reduce overproduction as you can produce single-digit lot sizes in a sustainable manner, and also by cost-efficient individualization, very close to the customer. And we, of course, are utmost eager to push this transformation, and we do see that there are remaining challenges. Now I highlighted those ones related to the technical part from process and application performance, but really we do see that polyurethanes could be an enabler, and therefore we have developed an entire toolbox that is meant to serve as an enabling material solution. And now I'm coming back, I think, to the point that many of you also mentioned yesterday. I think in this context, it's a lot about collaboration. So we have, for our part, looked into the material solution. It's also about the software, it's about the hardware, it's about the business models, it's about the designs. So I think this collaboration along the textile value chain is utmost critical. And what I would like to add to this one is that not only within the textile industry, I think there's a collaboration needed in this context, but it's also about using cross-industry experiences and discussions. And this is what we do internally within Covestro with the colleagues from packaging, but also mobility. And allow me to kick it off with a video, hopefully with sound if possible. Okay, so with this one, allow me to end the presentation and just let me say, let's push boundaries in digital textile printing together. I'm now utmost curious about any questions you may have, and thank you very much for your attention.
Any questions from the audience?
Thank you for the presentation. I was just curious as to how much demand for pigments has increased as a result of the current energy crisis.
If you mean if we have seen an increase in this one, allow me to be honest on this one. This is a fairly new field for us. So we do see that there's an increasing demand ever since we somewhat also openly communicated that we are active in this part, but I've not yet seen any sort of correlation with, resources or energy consumption with regard to increased number of demands. We do see a lot of demands, which is good, I think, but I have no comparison, so.
I do have a question from a remote attendee. They're asking, how far are we from printing with pigments without the need for pre-treatment?
That's a very good question. So as I've also shown earlier, I think it's, if you really want to tackle high quality printed images, it's still as of today needed to apply the pre-treatment. But also, as you've seen earlier, maybe you recall the image with the fastness properties of the polyester substrate we printed on. So just from the rating of the fastness properties, this was really, really good. So we would dare to say that polyurethanes are a suitable material solution to really also get rid of the pretreatment. But also on our end, we are working on maybe even more durable material solutions to really get rid of the pretreatment, or to avoid any sort of also soaking of the ink into the textile substrate, which I think of course is quite critical. So having this crashing or maybe crashing behavior that you would normally see on the pretreatment that allows for quick drop fixation is of course something that would have to be somewhat replaced by maybe a more thixotropic material, etc. So this is something that we are looking into.
Any questions from the audience here?
Good morning. My question is about hand fill. So how can you cope with this key requirement in textile with polyurethane-based solutions? So are you satisfied with the hand fill reach so far and so on? This is the question.
Yeah, this is a very good question because, I mean, typically, as indicated earlier, we can control the hand feel by looking into the mechanical properties. Really, this modulus is for us an indicator about the final hand feel. So with anything, I would say below 4 or 5 megapascal, we do see that we have good handle properties. But handle, on the other hand side, of course, is a super subjective matter. And what we are doing at the moment is we are learning from our colleagues actually from the packaging industry, who are looking into a lot of matting agents who have a so-called field panel. And what they do is pretty much they can, or they have a distinguished round of experts who pretty much touch any kind of surfaces, I would say, and evaluate those with regard to velvety feel, with regard to how to say, slipperiness, I believe that. So they have like a bunch of different criteria with which they then evaluate the handle properties. And this is also something that we are doing right now to really have a more, I would say, objective way of really judging the handle properties. Because in the end, it's really about your personal preference, I would think.
Any other questions? No. There's one. Okay.